Good morning, students. Now, as you can see in this lecture, we are going to talk about resource allocation graph. This is a tool used in our recovering from the deadlock detection and deadlock recovery में use होता है resource allocation graph. Now, as it says, resource allocation graph is the peculiar state of a system, as its name suggests. The resource allocation graph is the complete information about all the processes which are holding some resources or waiting for some resources. Means if there are n number of processes who are competing with each other and the n number of resources that are present into the system that can be allocated. What is the relation amongst these competing processes and resources and their instances is depicted in a graphical format through this resource allocation graph. So in this we'll find out, before that we should know what are the symbols that are used for it. It also contains the information about all the instances of the resources, whether they are available or being used in the process. In a resource allocation graph, क्योंकि graph है तो obviously it is going to be a set of vertices and edges. Vertices क्या होंगे इसमें? The processes and the resources. Generally किसी भी graph में vertices केवल nodes which are represented by circles are the vertices of a graph. But this is a special kind of a graph जहाँ पे vertex दो shape में होंगे. एक circular form में which is going to be representing the number of processes in the system. और दूसरा वर्टेक्स का फॉर्म होगा रेक्टेंगुलर इन शेप. रेक्टेंगुलर शेप विल बी रिप्रेजेंटिंग द नंबर ऑफ रिसोर्सेज इनटू द सिस्टम. और इन रेक्टेंगल्स के बीच में आप देखेंगे डॉट्स होंगे. वो डॉट्स रिप्रेजेंट करेंगे द नंबर ऑफ इंस्टेंसेस ऑफ दोज रिसोर्सेज. सो आई रीड इट फॉर यू. Vertices are mainly of two types, as I said, resources and processes, and for both of them we have different symbols. It says each of them will be represented by different shape. Circle represents the process while rectangle represents the resource. Okay, and next, a resource can have more than one instance. Each instance will be represented by a dot inside the rectangle, as I say. Edges in the RAG, that is a short form for resource allocation graph. Edges in RAG are also of two types. One represents assignment and the other represents the request या wait of a process for a resource. Okay, so this is a symbol. In this example diagram you can see एक edge है जिसमें arrow process से resource की तरफ आ रहा है और एक edge है जिसमें arrow resource से process की तरफ जा रहा है. Okay, when the arrow is pointing from the process to the resource, this is a requesting. Process wishes to have this resource या process request to have this resource, तो wait कर रहा है वो assignment के लिए. जबकि अगर कोई arrow is moving from the resource towards the process, so this is a resource has been assigned to this process, that is this process is already holding a resource. Understood? So this is a request edge and this is a assignment edge. If a cycle is being formed in a resource allocation graph where all the resources have the single instance, then obviously you can find out without any calculation the system is in a deadlock state. In case of a resource allocation graph with multi-instance resources, then cycle is a necessary condition of deadlock but not the sufficient condition. Means अगर multiple instances हैं किसी resource के, किसी resource allocation graph में दिख रहे हैं, तो cycle होने से deadlock होना निश्चित नहीं है. एक रीज़न हो सकता है बट इट इज़ नॉट ऑलवेज ट्रू कि साइकिल है तो डेडलॉक होगा ही. इसके लिए वी हैव टेकन अप एग्जाम्पल. दे आर 3 प्रोसेसेस. ये बहुत कॉमन एग्जाम्पल है जो शुरू से ले रहे हैं. P1 is requesting for R1 but P1 is already holding R3. P2 is holding R1 but requesting for R2. P3 is assigned R2 but is requesting for R3. So ये क्या है? सर्कुलर वेट है. P1 is waiting for R1, P2 is waiting for R2, P3 is waiting for R3. तो हर एक प्रोसेस किसी रिसोर्स का वेट कर रहा है. यू कैन सी ये असाइनमेंट मैट्रिक्स है जिसको हम एलोकेशन मैट्रिक्स भी बोलते हैं. P1 is allocated the resource R3, P2 is allocated R1 and P3 is allocated R2. ये allocation matrix है जिसको हम एलोकेशन मैट्रिक्स बोलते हैं। दूसरा बनाते हैं रिक्वेस्ट मैट्रिक्स। रिक्वेस्ट मैट्रिक्स में P1 इज रिक्वेस्टिंग फॉर R1, P2 इज रिक्वेस्टिंग फॉर R2 एंड P3 इज रिक्वेस्टिंग फॉर R3, राइट। नाउ अब क्योंकि 3 रिसोर्सेज है, तीनों के सिंगल इंस्टेंस है और तीनों रिसोर्स ऑलरेडी 3 प्रोसेसेस को असाइंड है, तो अवेलेबल फ्री अवेलेबल रिसोर्सेज अभी कितने हैं हमारे सिस्टम में? 0,0,0 मीन्स R1, R2, R3 की कोई भी इंस्टेंस इस वक्त फ्री नहीं है। Neither we are having any resource available in the system, nor process is going to release it. Each of the process needs at least a single resource to complete. Therefore, they will continuously be holding each one of them. We cannot fulfill the demand of at least one process until the available processes resources. Therefore, the system is deadlocked. क्योंकि साइकिल थी और हमने इस ग्राफ के थ्रू, मैट्रिक्स के थ्रू भी जान लिया कि there is a deadlock situation. Now, Banker's algorithm is another way to resolve this deadlock situation. Okay, what is Banker's algorithm? We'll quickly have a look to it, and don't forget, in your lab assignment sheet, you were supposed to make a program in C on Banker's algorithm, right? So you can make this program only once you have understood the working of this algorithm. So just pay attention to it. For resource categories that contain more than one instance, the resource allocation graph method does not work, as I've said, and more complex but less efficient methods must be chosen. The Banker's algorithm gets its name because it is a method that bankers could use to assure that when they lend out resources, they will still be able to satisfy their clients. इसका एग्जाम्पल है कि अगर कोई बैंकर है, वो लोन देता है अपने क्लाइंट्स को, तो वो एक लिमिट में ही लोन देगा और उतना ही देगा जितने से उसके बाकी क्लाइंट्स अफेक्ट ना हो। ऐसा नहीं करेगा कि उसके पास जितना कॉर्पस है, जितना पैसा है, वो सारा एक ही क्लाइंट को लेंड कर देगा, ना, कभी नहीं करेगा। A banker won't loan out a little money to start building a house unless they are assured that they will later be able to loan out the rest of the money to finish the house. Okay, so let's see what is it. When a process starts up, it must state in advance the maximum allocation of resources it may request up to the amount available on the system. When a request is made, the scheduler determines whether granting the request would leave the system in safe state. Safe state से मतलब है a state where deadlock is not happening. If not, then the process must wait until the request can be granted safely. The Banker's algorithm relies on several key data structures. Key data structures इसमें basically arrays होती हैं, matrix होती हैं basically. Matrix क्यों बोलते हैं? Because they are a double dimensional array plotted across the processes and the resources, where n is the number of processes and m is the number of resources categories. Available m, that is the array, single dimensional array, which will hold the list of resources, indicates how many resources currently available of each type, right? तो अगर there are 3 types of resources, तो matrix available matrix का size क्या होगा? 3, और resources के numbers क्या होंगे? resource 0, resource 1 and resource 2. और इस matrix की जो entries होंगी, array की जो values होंगी, वो number of instances बताएंगे। अगर array available array 3 size की मेरी है 2, 4, 5, तो मतलब 0th रिसोर्स के 2 इंस्टेंसेस, फर्स्ट रिसोर्स दैट इज सेकेंड रिसोर्स के 4 इंस्टेंसेस, और थर्ड रिसोर्स दैट इज अवेलेबल मैट्रिक्स इंडेक्स 2 के 5 इंस्टेंसेस will be there. So available matrix is going to tell me the number of instances and the number of resources. Matrix max n by m indicates the maximum demand of each process of each resource. किस प्रोसेस की मैक्सिमम कितनी डिमांड होगी किस रिसोर्स की, वो हम n by n मैट्रिक्स में बताएंगे. n इज द नंबर ऑफ रोज, रो बाय कॉलम मैट्रिक्स होता है, तो n इज नंबर ऑफ रोज, दैट इज नंबर ऑफ प्रोसेसेस, एंड m इज द नंबर ऑफ रिसोर्सेज, दैट इज द कॉलम्स. Allocation matrix will indicate the number of each resource category allocated to each process. मैक्सिमम इतना चाहिए, allocated इतना है, तो नीड कैसे निकालेंगे? नीड विल बी इक्वल्स टू allocation माइनस मैक्स, सॉरी मैक्स माइनस एलोकेशन. तो इस फॉर्मूले से मेरी नीड निकल आएगी कि हमारे पास इतना चाहिए था, इतना है, और अभी इतना डेफिशिएंट है. और इसके लिए आई हैव गिवन यू दिस एग्जांपल ओवर हियर, एंड थ्रू दिस एग्जांपल यू कैन कैलकुलेट द नीड ऑफ द